Hey class, this is lesson 323, interpreting comparisons. Before I get into this, I want to talk a little bit about finding sales tax. So I just want to do a couple problems finding sales tax. So in the state of Minnesota, the sales tax rate is 6.875%. Let's say I wanted to find sales tax on an item that I paid $10.99 for. Well, one way you could do that is by setting up a proportion to find out what the 6.875% is. And this would be the whole amount, and the tax would be the part. So that would look something like this. B over 1099 is equal to 6.875 out of 100, since the 6.875 is the percent. And to find the answer, we would take 1099 times 6.875 and then divide that by 100. And if you do that, you get and if we round it to the nearest cent, we get 76 cents. So that's just the tax part. If we want to know how much we would pay for the item, we would have to add 1099 plus 76 cents, which is $11.75. Now, another way to use that proportion, it would be to take and think about if I need the price with the sales tax anyway, I can think of this 1099 as 100% of the price. So if I add sales tax, which is 6.875%, onto that, the price with tax is actually going to be 106.875% of the sale price. So if I use that in my proportion, I would get, so I'm going to put my 1099 as my whole, and I'm going to use 106.875 as my percent, and that's out of 100, of course. And then my part is the price with the sales tax, which is 106.875% of the price. So now when I do the math, and I round it to the nearest cent, so I'm multiplying these two numbers and dividing by 100, I get my 11.75 in one step by doing it that way. Now, one more thing I'd like you to think about is this. Since I'm eventually going to divide by 100, I could just divide my 106.875 by 100 first, and I get 1.0685. If I multiply that, any price by that amount, I will get the price with tax. So I can really simplify this process by just taking my $10.99 times 1.086875 to get my price with tax, which is equal to, when rounded to the nearest cent, $11.75. And this works if I want to do a different percent, like let's say I go to Wisconsin and sales tax is 5.5%, I just have to do my 5.5% would be 105.5% when I include my price. And so if I bought this item for $10.99 in Wisconsin, I would multiply by 1.055 to get my price after tax, and 10.99 times 1.055 equals $11.59. So the same item for $10.99 in Wisconsin would cost $11.59. All right. The lesson today is using ratios and percents to compare things. So here we are in a recent election by 7th grade class with 90 students. So that's an important number. Razi received 36 votes. You get 36. And Jorge received 54 votes. Now notice that if I add 36 plus 54, the total number of votes is 90 votes. So every student voted. Now, what we want to do is tell whether each of the following statements presents this information accurately. For each statement, explain or give a calculation to show why it's accurate. So the first one says the ratio of the number of students who voted for Razi to the number who voted for Jorge is 2 to 3. So we need the number that voted for Razi, and we're going to compare that for the number to the number that voted for Jorge. Well, Razi got 36 votes. Jorge got 54 votes. So we're going to do 36 over 54. And if we simplify that, we might notice that both these numbers are divisible by 18. 36 divided by 18 is 2. 54 divided by 18 is 3. So we get the exact same ratio. So this one is accurate. So we'll just say yes, it's accurate. And here's our workshop. All right. The part B says 40% of the voters preferred Razi. 40% of the voters. So of the voters, so we need a different number here. We need 90 because there's 90 voters. And 40% of the voters preferred Razi. So how many preferred Razi? That's 36. So 36 out of 90 voted for Razi. So we want to change that to a percent. 36 out of 90 equals how many out of 100? Because we want the percent. And if we multiply 36 times 100 and divide that by 90, we get 40. And since it's 40 out of 100, that's 40%. So yes, this is accurate. And there's our work. Okay. Jorge received 20% more of the total vote than Razi received. 20% more. That sounds like a percent increase. Well, Jorge got 54 and Razi got 36. If we subtract those two, we see that Jorge got 18 more votes than Razi. And 18 out of the total, which is 90 students, so we want that to be a percent, 18 out of 90. And that is what number out of 100? So we're going to take 18 times 100 divided by 90, and that gives us 20. So 20% more. That's a percent increase. So yeah, that's accurate. And there's our work. All right. 50% more people voted for Jorge than for Razi. 50% more people voted for. So we want to look at the number that Razi got. Razi got 36 votes. If we were to increase that by 50%, now here's where I would do. So let's use our 36 as our whole. If we increase that by 50%, that means we're increasing our whole, which is really 100% by 50%. So that would be 150% of the 36. And so if I take 36 times 150 and divide that by 100, I get n is equal to 54, which is the number who voted for Jorge. So that is accurate, yes. 50% more people voted. Another way we could get that same answer is by thinking about, so Jorge got 54 votes, Razi got 36. If we take 54 minus 36, we see that he got 18 more votes. And if we compare that to how many Razi got, 18 out of 36 is equal to 50%. So 50% more votes. Okay. E, 18 more people voted for Jorge than Razi. So 54 minus 36 equals 18. Yes, 18 more people voted for Jorge than Razi. Yes? Boy, a lot of yes answers here. Jorge received 3/5 of the votes. So that's of the total vote. So this one is out of 90. Jorge received 54 votes. Is 54 out of 90 equal to 3/5? We need to simplify that. If we divide 54 by 18, we get 3. So we're dividing both of these by 18. 90 divided by 18 is 5. So yeah, Jorge did get 3/5 of the votes. All right. The number of people who voted for Jorge is 1.5 times the number that voted for Razi. So the number that voted for Razi is 36. If we multiply that by 1.5, we get 54, which is the number that voted for Jorge. So that is accurate, yes. All right, so now we have to think of, all of these are accurate. Which seems to give the best impression of the class's preference for Jorge? And why? I think that's a good question for us to decide in class. Which one? Which of the accurate statements in exercise 1 seems to minimize the class preference? Again, we'll talk about that in class. All right. Some ratios compare a part of some group to the whole group, like the 36 students who voted for Razi compared to the total number of voters, 90. Such ratios are called part to whole. So if we're talking about the whole group, out of the whole group, which in this case is out of 90, then we're talking about part to whole, some number out of 90. Other ratios compare part of the group to another part of the different group, like the 36 who voted for Razi compared to the 54 who voted for Jorge. So 54 is part of the total, and so is 36. Those are called part to part. Which statements in exercise 1 make a part to whole? I'll give one example, but I can give the rest. But anytime we're comparing to 90, like 40% of the voters, so I'm going to use that as an example. That's a part to whole. 40% of the students, because it's talking about all the student populations, preferred Razi. That's an example of a part to whole. A part to part comparison would be saying something like 18 more students preferred Jorge. Because we're comparing it to the 18 more, we're comparing the 36 that Razi got to the 54 that Jorge got. And so it's part to part in this case. All right. I think the rest of them we can do in class. And I'll see you tomorrow.